So, hi everyone. It's really good to see you all here. Thank you for joining and welcome. We've got a really exciting discussion for you today. So as you all saw on the landing page, the topic of today's discussion is a deep dive on endurance biomarkers. I think you all know, but my name is Roe Metzer. I'm the Director of Business Development at InsideTracker. But today you are going to learn from InsideTracker's lead nutrition scientist and sports dietitian, Ashley Reaver. So Ashley's been with InsideTracker for more than 7 years, 7.5. She's a certified sports dietitian. She received her undergraduate degree in nutritional sciences and dietetics from Cornell, and her graduate degree in nutrition science and policy from Tufts. She's a dietetic lecturer at UC Berkeley and has completed numerous half marathons and 2 half Ironman races. She's a friend. She's an incredible dietitian and an incredible person. And I'm pretty pumped for all of you to learn from her today. So today, our objective is to arm you all with information and knowledge that's going to help you get the most value out of InsideTracker and that data that your clients are going to get when they do an InsideTracker analysis. So Ashley's going to dive pretty deep on the biomarkers that are most critical for optimal endurance and provide you with the information we believe you need to make the most of this data and help your clients achieve their goals. So there's just 2 asks that I have before we get started. The first is that if you're able to, I would sincerely appreciate if you can turn your camera on. Everyone here today is an InsideTracker Pro, and we have an amazing community of professionals in this program. And my goal for these webinars, this is the first in a series of them, is to arm you all with knowledge, but also to give you all an opportunity to meet and connect with each other. As the world has gone virtual, especially over the last year, and I know that many of you are working mostly remote with clients as well, I think it's critical that we create human connection wherever possible and as much as possible, and this is one small way for us to do that. I hope one day that we can do these in person. But for now, this is going to have to do. So I ask that you be visible if you can. And the second ask I have is this session is really meant to be interactive. So Ashley is going to spend the first portion of today going through the material that we have planned. And then we're going to have dedicated time at the end for Q&A. So if you have questions, and I hope you will, please just write them in the chat and send them in the chat. And then as they come up, just write them. And then at the end, we're going to open it up for Q&A, and I'll call on you to ask Ashley your question directly. And I ask that you don't be shy, please. There are no bad questions. We've done this and organized this session for you, especially, and Ashley is here to help you. So please take advantage of that. So given how much material there is to cover, we're actually going to break this into 2 parts. The first part today, we're going to cover nutrients. And then in part 2, we're going to cover hormones and markers that are related to overtraining, and that's going to get scheduled at some point in the next few weeks. And of course, we'll let you know as soon as we have a date. Quick reminder that this is going to be recorded. You can probably see that it's recording now, and we'll share the recording with you once we're done. So with that, I am going to turn it over to Ashley. She's somewhere here on the screen. Ashley, the floor is yours. Okay.
Thanks, Roy. I am just going to share my screen and head into present mode. Roy, can you give me a thumbs up if you can see that? Okay, awesome. Hi, everybody. Roy, thanks for that nice intro again. As Roy mentioned, we're going to kind of split up what we're going to cover. As we were making these slides, our original goal was like 30 to 40 minutes, and I just can't cut myself off at 30 minutes talking about all the markers that I want us to go through. So the ones that we're going to start on today are really focusing on nutrients. Primarily, we're going to be looking at 3 nutrients in particular. So vitamin D, vitamin B12, and iron. If you all have tried to walk through even your own results or results with maybe one of your your athletes or clients, you know that that iron group is a bear. I could probably spend 30 minutes talking on ferritin alone. So I'm going to do my best to try and keep it short. We put a lot of info in the slides, and I know Roe's also going to send these out to you all after the session. And then next session we'll go into hormones and some markers of overtraining and muscle damage. So getting started with our part 1, focusing on nutrients, I'm going to dive into vitamin D first. How all the slides are set up is kind of just an overall, or I should say a high level view of what the marker is, what it does, where it comes from. And then we'll walk through some examples of each of the biomarker states, why nutrients could be high or low. So starting with vitamin D is a fat soluble vitamin. It is fat soluble, meaning that 1, we absorb it best when we eat it with other sources of fat, and 2, that our body's able to store it. Like most other fat soluble vitamins, we don't only store it in our fat tissue, we also store it in our liver. And vitamin D has gotten a lot of popularity recently. But why vitamin D is an essential nutrient, meaning one that we have to get from outside of our body, is because it's incredibly important for regulating the absorption of calcium. So vitamin D's role in the body is really to go to our intestinal tract and absorb more calcium from the intestinal tract. And it does that by a series of steps, but it's triggered when our blood levels of calcium are low. And that's why vitamin D is often tied to bone health, because if we don't have adequate levels of of vitamin D in our blood or in our body, then we're not able to absorb adequate amounts of calcium from the digestive tract. And therefore, our body still has to use calcium for all sorts of reactions, plenty of things, including muscle contraction, but that has to pull that calcium from the bone. So that's that strong connection there. I know vitamin D has gotten a lot of buzz for immunity, even some things related to athletic performance, but it's still important to think about as a marker that's so integral for bone health. Many people that have worked for athletes for a long time know that stress fractures are something that are really common. Low levels of vitamin D are one of the markers that are certainly associated with an increased risk of stress fractures as well. So that's kind of a high level on what vitamin D does in the body. Where we can get it, there's really 2 different forms of vitamin D, as I'm sure you're familiar with. Both forms of vitamin D do the exact same thing in our body. We have vitamin D3 that is produced in our skin. The UV rays from the sun convert a type of cholesterol found in the skin into an inactive form of vitamin D that hangs out until our calcium levels drop down, and that signaling cascade happens to activate that vitamin D to then head to our intestinal tract to absorb some calcium. The other way that we get vitamin D is through our diet. About 80% of the vitamin D that most of us get comes from this vitamin D3 from the conversion in our skin. And that's because vitamin D2 is actually a pretty rare nutrient to find in foods. It's not common in a lot of foods. Cod liver oil, fatty fish, eel, fortified products are really the only places that we can find vitamin D. And just like vitamin D that we would make in our skin, this vitamin D that we eat from foods is also converted to an inactive form where it gets stored until our body really needs it. Reasons why your vitamin D level could be optimized, which is great. Again, about 80% of our vitamin D needs are assumably met from the production of vitamin D3 in the skin. The other 20% is what our body kind of would normally rely diet or supplement to help make up. So if someone has an optimized vitamin D level, this, I'm sad to admit, is my vitamin D level, which is right on the bottom of our optimal zone at my last test. There is a good combination of either exposure to the sun, adequate vitamin D from fortified foods in the diet, or taking a supplement in order to make sure that my vitamin D stores are high enough. One important thing that I just added here is, and this is something that we get asked quite frequently. Let's say someone has a lower level of vitamin D, maybe they're in that low red zone. They start taking a 5,000 IU supplement. It gets up into this optimal zone. what do? Do you stop taking a supplement? Oftentimes, I would typically recommend that individuals just drop back on their vitamin D supplement once they hit that optimal zone, because it's clear that one of the factors in lifestyle or diet isn't kind of meeting the needs of providing enough of that vitamin D. It could go back from, especially if you're low, our recommendations 5,000 IUs. Once you hit that optimized zone, depending on where you are, you can drop back from taking that maybe once a day to only taking it once or twice a week. Since it's a fat soluble vitamin, we don't need to take it every single day. So that's certainly a nice part of vitamin D, but also incredibly important for a follow-up test for people to get their vitamin D tested again within 3 months, because you certainly can reach toxic levels of vitamin D as a fat soluble vitamin. And truthfully, that's happening much more frequently now as the research from COVID-19 that kind of hit last year, saying that individuals with lower levels of vitamin D were associated with poor outcomes once they were hospitalized. I think that there's a lot of association in that, not necessarily causation, but there's been a lot of mega doses of people taking 10,000 plus IUs of vitamin D each day. So following up, getting that level retested to make sure that your supplement is still needed and at that specific dosage, I think is a great insight that a coach can also make for athletes. Reasons that vitamin D could be low. As I mentioned before, it's related to an increased risk of stress fracture. How blood calcium kind of works. If you were looking at your own results, we didn't put calcium into this, but for the most part, your calcium level is pretty stable. And that's because if you don't consume enough calcium in your diet, your blood has that big reservoir of calcium in your bones that it can pull from in order to maintain those blood levels of calcium. So again, having low levels of vitamin D, if that impairs the amount of calcium that can be absorbed from the digestive tract, that doesn't mean that your body gets by on less calcium. It means that your bones become the primary source for that calcium. And in particular, if you combine that with a very high training load, inadequate calorie intake, that drastically can really increase the risk of stress fractures, particularly also in female runners that may have lost their cycle. Other things that vitamin D can do, again, could have an impact on immune function, since it functions much more similarly to a hormone as opposed to a cofactor or almost like an enzyme, which most of our water soluble nutrients do, and then can also influence skeletal muscle maintenance over a certain level. And there was a couple really cool studies that came out maybe 8 years ago at this point that were looking at athletes that primarily trained in southern sunny states. So one study focused on NFL players in Texas. Another study looked at MLB players during their spring training in Florida. And even though those individuals were spending a lot of time in the sun, there were still a large group of them that had clinically low levels of vitamin D, so below 30. And in those studies, it also, took one step further and looked at their likelihood of getting their contract re-signed. And individuals that had lower levels of vitamin D had less likelihood of having that contract re-signed. And most likely it was because they had some sort of injury that led to that. So an interesting study that just really, again, ties back the importance of vitamin D for athletic performance. As I mentioned, that deficiency is pretty common. Especially if you live in the Northeast where InsideTracker is. Even individuals that do have a lot of sun exposure, though, can still be at risk of vitamin D deficiency. And these 8 bullet points here are kind of all focusing on sun exposure for vitamin D. So these are all things that can influence whether or not the time you're spending in the sun is actually fruitful in your attempt to produce enough of that vitamin D3 in the skin. Location's a big one. Maybe this is one that you are familiar with, but essentially it's the 37th parallel across the United States, which is about San Francisco over to Gettysburg, Pennsylvania. If you live above that 37th parallel, between November and April, roughly, we are shifted away from the sun as we're in wintertime. And the sun is not strong enough at that point of the year, living above that 37th parallel to be able to produce that vitamin D in the skin. So athletes that still maybe are running outside in New Jersey through that time period, even though they're in the sun exposure that they're having isn't strong enough to really produce that 80% of vitamin D that they may be depending on. Season certainly plays a role as well. Again, especially during wintertime, as wintertime in the northern hemisphere, as the earth is tilted away, those UV rays aren't quite as strong. Time of day has a big influence. Morning sun tends to be the strongest and therefore can lead to the highest production of vitamin D. If you're trying to get in your sun exposure during sunset hours, you're likely not going to be able to produce very high amounts. Skin color has a really big impact as well. Individuals with darker skin have more melanin in their skin. Evolutionarily, that was a protective mechanism for just being protected from all of that exposure to UV rays. However, as a lot of individuals that may not have ancestry from certain areas in the United States, in particular in that northern half of the US, if you have a darker skin tone, you require more sun exposure to be able to produce enough vitamin D from the sun. So a lot of individuals that have darker skin tones that are living in Michigan, let's say, sun exposure during November to April isn't doing much. And sun exposure, even during the summer, while most individuals might be, well, I shouldn't say most, while individuals with less melanin in their skin may be able to achieve adequate vitamin D production in 20 minutes, those with more may require up to double the amount of sun exposure to be able to produce the same. Age is a factor. As we age, that conversion of the 7-dehydrocholesterol in our skin into vitamin D3 decreases. So reliance on just the sun for energy, for vitamin D also goes down. Sunscreen, if you are wearing SPF greater than 15, no vitamin D production is happening in the skin. Clothing, if you're wearing sleeves, a hat, long pants, anything like that can also have a big impact as well. And that's really why, a lot of our, let's say, baseball players in Florida, they're outside in the sun hours each day, but they're coated in sunscreen and maybe the tip of their nose is exposed to sun, and that's kind of it. The last fact here is just diet. As I mentioned before, there's really not a good source of vitamin D in the diet. Cod liver oil is actually what they use to discover vitamin D. That cod liver oil could recover or help to repair the effects of rickets in dogs, which is a fun fact. But dairy products are fortified. Non-dairy products are typically fortified to compete with dairy products. And then fatty fish is also a source where you might find some. Truthfully, if you have clinically low levels of vitamin D, it's worth taking a supplement to help to lift you kind of out of that gutter and start to rebuild your body's stores of vitamin D. Once they are higher, again, you can certainly probably back off of that dosage, or depending on the time of year, you might be able to maintain that level through just diet and sun exposure. Below optimized is kind of our next one. There's a really small window of optimized or between optimized and normal low. So it's only 30, 31, and 32. For athletes, ideally, you're not going to be hovering on that bottom of the optimal zone. If you only have a few points to go up here, again, you could focus just on trying to get more unadulterated sun exposure. So spending 10 to 15 minutes outside in the sun without sunscreen or clothing on a large portion of your body. You could try and intake more of those fortified sources of vitamin D, whether that be cow's dairy, fortified plant-based milks, or you can certainly also find vitamin D fortification in some cereals, or again, focusing kind of on a lower dose, maybe 1000 IU supplement, just to help get you that last little boost. High vitamin D, again, this is something that is a bit more frequent now, especially for individuals that are deep into the health and wellness space. And maybe are big fans of supplementation. So something certainly to watch out for. The side effects of high vitamin D, knowing its role in the body, can cause excessive absorption of calcium from the digestive tract. And it would be great if all of that calcium just got deposited into the bones. That's not the case necessarily. Calcium, as well as other minerals, if there's too much of it, can start to deposit itself in the soft tissues. In particular, those soft tissues are your joints, your muscles, and your organs, which include your heart, your pancreas, and your brain. So some symptoms of high vitamin D could be weakness, joint pain, or even kidney dysfunction if it's too high. So if you see athletes that are up at 80 and they are still supplementing with 5,000 IUs, recommend that they drop that back for quite a while, and get their blood retested to see if and when they might need supplementation again. All right, next one, rolling into B12. So vitamin B12 is a water-soluble vitamin. It's the only water-soluble vitamin that we'll probably even talk about. We also test folate, but all the other water-soluble vitamins are very, very difficult to test in the blood because it's not a stable marker. In our body, B12 is kind of a hybrid between a water-soluble vitamin, which our bodies can't store. We need to have basically every day. You might be able to get by with every other day. And our fat-soluble vitamins, which we don't need every day because we can store them in the body. B12 we can store in our liver for about 2 years. And that's certainly an important fact for individuals that are maybe trying out a vegan diet, if they haven't done a lot of education up front on the nutrients that they really need to pay attention to. For B12, they have about 2 years until some serious side effects can happen. B12 is a coenzyme like many of the other water-soluble vitamins. Essentially, it is one part of an enzyme that has an influence on some type of metabolic reaction. For B12 in particular, it plays a really important role in the formation of red blood cells in our nervous tissue, as well as in the production of DNA. Where it comes from, this is always an interesting note. So vitamin B12 is made by bacteria. We as humans produce it in our gut, but we produce it too low in our intestinal tract for us to be able to reabsorb it and actually be able to utilize it. Other animals produce it in their digestive tract as well. One thing that's interesting to note is that other animals don't wash their food before they eat it. So it leaves the gut bacteria of one animal may be found on the food of another, and that's how animals are able to get in enough of their B12. Cows have a multi-compartment stomach, and where B12 is produced in their stomach, it's absorbed in a later part of it. So that's why animals don't require B12 supplementation. If you would like to live on top of the grass and things that you end up eating and never washing it, you too may be able to get by without a B12 supplement if you don't eat animal products. But that's where we really find it in the diet. It's stored in the liver as well as the muscle of animals and humans. And it's also found in any type of animal product. So you're going to find it in meat, as well as, dairy, cheese, those types of things. You can find it in fortified plant foods, non-dairy milks. So, your almond, soy milks, pea, whatever else you can find out there. Most of them are fortified to compete directly with the type of I can't mute, Rowie. You might have to do that. Although, good song. All right. So non-dairy milks is a really great place to find a fortification of B12. You can also find it in a lot of fortified cereals. Sneaky sources of it are energy drinks have a ridiculous amount of B12. Pre-workouts, if you are, especially we find these in strength athletes a lot, but pre-workout drinks are basically powdered caffeine and B12. And then you can also find it in really high amounts in all sorts of supplements. So if you take a focus supplement or an energy supplement, certainly you find it in B complex as well as multivitamins as well. Optimized vitamin B12 just indicates that you're taking in enough either through your diet or through supplementation. Low levels of B12 can be incredibly serious. On our kind of ranking of biomarkers in the back end of the system, clinically low B12 is the highest marker that we have. It's ranked our number one of importance that we want someone to know immediately that they need to either go get a B12 transfusion, injection, whatever they'd want to do, or start a really high dosage of supplementation right away. And that's because of B12's role in nervous tissue formation as well as DNA formation. or the protection of DNA and the formation of RNA. It can cause irreparable damage to your nervous tissues. Irreparable meaning that, you played around with a vegan diet for 2 years. If your B12 levels tanked, and you weren't supplementing and you didn't notice it for a while, it can start to cause some neurological issues that will persist. Low B12, we'll talk about this a little bit when we get into some of our iron markers, can also be a cause of macrocytic anemia. And then that fatigue and brain fog in particular. Individuals that are most at risk for low B12 are those that just don't consume animal products and don't supplement. So vegans are at highest risk without supplementation. Vegetarians, if they include dairy and eggs, are at a lower risk, but still definitely a nutrient to watch. And then older adults, in particular older athletes as well, the absorption of B12 really decreases as we age. B12 is probably the most difficult nutrient for our body to absorb. There's a lot of things that must be true in order for absorption of B12 to finally happen pretty late in the top of our intestines. That absorption becomes more difficult with age. So it may be best for some older individuals to focus on supplementation or fortified forms of B12, like you can find in cereals and non-dairy milks, as that fortified form of B12 is much more readily absorbed. Below optimized B12, so our clinically low zone, which is the defined clinically low zone for B12, is at less than 200, but there are some side effects that have been shown that can start before being clinically deficient. For individuals that have markers that have B12 less than 350, a supplement is definitely warranted. Our optimal zone starts around 450. If you're in that 350 to 450 range, having an extra glass of almond milk a day or switching your cereal to one that's fortified with B12 could help you make up that gap. Less than 350 though, you don't want to mess around with that. It's worth taking a lower dose supplement. As we'll see, high B12 is something that's pretty common. And then again, just figuring out what is the right cadence and the right dosage to keep you within that optimal zone. Most B12 supplements that you'll find on the market are thousands of % more than the daily value. Finding a B12 supplement that actually gives you 100% of the daily value of B12 is incredibly difficult. Costco's brand of vitamin B12 is 41,667% of your daily requirement for B12. And that's what leads a lot of people to have very, very high levels of B12. There's not any known side effects of it. It's generally considered safe, but it is very unnecessary. There's a lot of individuals that just take B12 kind of willy-nilly without knowing what their blood levels are because they've heard somewhere that B12 is important for energy. And while that's certainly true, you're not going to feel that fatigue you're not going to feel that fatigue if it's related to B12, unless you're deficient or below optimized in B12. If you eat animal products, there's a good chance you don't need a B12 supplement. So this is something, again, you might see quite frequently, because really we would only see clinically high levels of B12 if there's a very high intake of some sort of artificial or fortified source of B12. Again, it could be B12 supplementation itself. If they have a high B12 level and they've told us their supplements, they're also going to get a recommendation that tells them to stop taking a B12 supplement, a B complex, or a multivitamin. But intake of fortified foods is also, again, something that's kind of sneaky. Protein powders can have a lot of B12 in it, those pre-workouts for sure. Again, B12 is just kind of a nutrient that's now really used in marketing, which is a bummer because it shades the true people that really need B12. Energy drinks are also really, really high in B12. And energy drinks aren't just monster drinks. You can certainly find some companies that, tout themselves as being the best type of energy drink for endurance. And it's really just a B12 bomb. Best energy drink you could really have is just coffee. Same thing with above optimized. There's no known side effects for it. Really, again, it's just figuring out what's causing that. For most people, if you're in the high red zone, it's because you have a supplement or some sort of fortified foods. Above optimized, if it makes sense for their other markers as well, you could cut back animal products a little bit, but there's no real known side effects for it. And B12 we included in this because it does, again, play a really big role in this iron group. So we'll get to those red blood cell indices kind of as one of our last slides, but ferritin, a marker that I could spend a ton of time talking about, is definitely a really important one for endurance. So protein, or excuse me, what it is, ferritin is a protein that your body produces in order to store iron. Since your body produces it in response to your iron stores, it's an indirect way to measure someone's iron status. It is an interesting marker in that it's also an acute phase protein. So we'll talk about that through a couple of slides, but it could be falsely elevated in response to some type of inflammation or infection, which kind of makes it, in my opinion, really, really great to be able to go through your InsideTracker results with a coach or someone that's familiar with how a lot of these markers interact. Because your ferritin could be falsely high, and therefore it's no longer a good marker of your iron status if it's high for reasons other than your iron stores. So ferritin has two kind of key roles where you'll find it. The first one is it's in our blood to store iron there, but another role, and an important role for ferritin, is that it's in the little fingers all over our intestines that absorb things. And ferritin, again, our body produces this ferritin in response to how much iron we have in our system. And if we have more iron in the system, our body puts more ferritin into these little fingers, or microvilli as they're called, in our intestinal tract, to bind to iron so that it can't pass through and be absorbed. Eventually those little fingers, they slough off every couple of days. So if you have a higher level of ferritin, your body's also protecting you from absorbing large amounts of iron from the digestive tract, so from your diet. And that's certainly part of the reason why, if you've been working on your ferritin, there is for sure a law of diminishing returns that applies. As your ferritin increases, it becomes much more difficult to continue to increase that ferritin. I certainly know that there are a lot of InsideTracker users that have been supplementing for a really long time with iron to try and get this ferritin to move. And that's why there's typically a kind of hard stop or a trickle effect of how much your ferritin can increase as you kind of continue to supplement. An interpretation of ferritin. So adequate levels of iron in your diet are one indicator, or could be one reason why your ferritin is optimized. I love ferritin kind of as an example of also thinking about InsideTracker's optimal zones. So your ferritin marker is also going to be dependent on the type of activity that you do. If you don't engage in a lot of physical activity, or you focus mostly on, let's say, strength, your ferritin optimal zone is going to start around 40 for women. If you are an endurance athlete, that optimal zone is going to be up closer to 60. And that's because your body requires a lot more iron when you're doing this, let's say, sport or sports activities that put a much higher demand on your body's ability to transfer oxygen. As I mentioned, ferritin can also be falsely elevated if there's inflammation that's happening. That inflammation, we would measure that as hsCRP, or white blood cells could also be really high. In that case, if you can see someone's hsCRP is sky high, then you want to look at their TIBC, and I have that as a marker in a few slides. And as an acute phase protein, it's great. And if we have some sort of invader in our body, let's say there's a bacteria or a virus that comes in, that also requires iron to be able to live and to multiply. So the body increases ferritin production to take some of that serum iron out of the blood into a form that whatever that invader is can't reach it. Low levels of ferritin, so can be caused by an inadequate intake of iron, which we'll talk about who might be at largest risk for that, but that's a big cause, as well as just excess loss of blood. It indicates that you have depleted iron stores, and ferritin is unfortunately not a marker that is tested if someone were to go to their physician. even though ferritin is kind of how you catch someone before they slip into anemia. You're going to see ferritin stores go down before you would see an impact on hemoglobin and then red blood cell production, and then the size and shape of those red blood cells. So ferritin for active individuals in particular is a super, super important marker. And a lot of that research that we have at InsideTracker on ferritin levels actually came from the US military, which is a pretty cool, like ultra extreme place to look at performance markers. Low ferritin levels, certainly if they are deficient in ferritin, you'll probably start feeling that fatigue. And that fatigue really is because oxygen is required for us to take the form of energy that we eat from food and convert it into the form of energy that our cells can use. Oxygen is the final step of our cells being able to kind of access energy. And that's why when you're exercising, your oxygen requirements increase so much, because your muscles have a much higher requirement for that ATP, which is the form of energy our cells can use, as you're asking them to contract over and over and over again. So in addition to just feeling, kind of crummy in your workouts, if you have a decreased ability to transport that oxygen and produce that energy, you can certainly feel bad every day. If you need a 2 o'clock nap and you're wiped out for 3 or 4 hours, ferritin is definitely a marker to check out. And certainly all of those are going to lead to poor athletic performance and just an athlete's ability to generate work or to do work with their muscles. Ferritin is, I should say, iron is the most common nutrient deficiency in the United States. And that's because a lot of premenopausal women are deficient in iron. Premenopausal, meaning that they have a regular loss of blood. The iron needs for females are more than double what they are for men. Pregnant females, it almost doubles on top of that. That's a lot of iron to eat, and it's pretty difficult. Not to mention sources of iron, maybe things that women choose to include in their diet in a lower either overall amount or lower frequency than men. Active individuals also have a higher requirement for iron and therefore ferritin, again, just based on that oxygen transport capacity that iron allows us to do with hemoglobin, which I'll talk about next. In addition to that, as particularly for runners, as your foot strikes the ground, when you are running, red blood cells that are running under your foot at that time can rupture. Then they have to be recycled and made into something new, but inevitably some of that iron that's in those red blood cells also gets lost. So that further increases the iron needs for active individuals. Individuals that also have a low intake of iron, again, many vegans and vegetarians don't consume foods that are high in iron. And the sources of iron that they do consume is a different form of iron that our body can't absorb. It has to be converted into the form of iron that you get from animal products. So that decreases the absorption a little bit, not to mention that there's also some nutrients that are also in foods that are high in iron that can bind to that iron so that we just aren't able to absorb it in the first place. Below optimized ferritin would signify that there's lower iron stores, again, before deficiency. If someone comes to you with a ferritin level of less than 10 or 11, I don't know how they're walking around. Truthfully, they should feel exhausted. We had an InsideTracker user the other day that had a ferritin of 3.7. And she figured it out because she was feeling tired. She couldn't go to work. That's bad for just living, but imagine athletic performance on top of that as well. Even if you're not deficient, though, feeling below or having a ferritin that's below optimized can still lead to some of those decreases in oxygen transport, as well as, again, declining the performance or work capacity that an individual has if they can't transport that oxygen efficiently to the muscle cells to be able to produce that form of energy our cells need. As I mentioned before, iron needs are higher in active individuals than non-active individuals, as well as higher in endurance versus strength athletes. High ferritin, it indicates an iron excess, or could certainly also be if there's really high levels of inflammation. Just like with calcium, as we talked about, if you have a very high level of ferritin without a ton of inflammation, truthfully, that really could indicate that you have high iron in your body. Just like calcium, that can start to deposit itself in your soft tissue, so your muscles, your organs, and your joints, and start to impact their function. Some things that are pretty cool about InsideTracker is I don't know how many people we have helped figure out that they have hemochromatosis, which is a genetic condition of absorbing too much iron. And this was before we had a DNA kit with it. I don't know, that's a cool thing about working with InsideTracker, is helping so many people realize that they had that condition and then what to do about it. Again, like I mentioned, inflammation is something that can really drive up that ferritin level, especially if someone does have enough iron stores. So for postmenopausal females as well as for men, if there is a red high ferritin, checking out that HSCRP in those white blood cells would probably be the first place to start. It would be pretty high to get red high ferritin just from inflammation for premenopausal females. And then excess iron intake is something that can also certainly increase that. We don't necessarily publicize what to do if you have very high ferritin levels, because you should go see your doctor. But giving blood is a great way to help rid your body of the cells that store the majority of the iron in our body, those red blood cells. Doing that pretty frequently, especially if you know anyone that has hemochromatosis, is a good treatment method for that. And pretty similar for above optimized, can mean there's excess iron intake in the diet, or it could be because of inflammation. Most likely it's only going to occur in males or postmenopausal females. Postmenopause, the iron needs of females come back down to equal males, which is about 8 milligrams of iron per day. Hemoglobin, I'm talking too much. So hemoglobin is a protein that contains iron that's found in our red blood cells, that binds iron and transports it around the body. So it picks up oxygen from our lungs, and then circulates that and distributes that oxygen to every single cell in our body. But in particular, on your muscle cells, it deposits that oxygen in myoglobin, which is another protein that just stores oxygen in your muscle cells before it can be used for that production of ATP. Hemoglobin is produced in your bone marrow, which is where your red blood cells are also produced, and it goes into your red blood cells as they come out. This is just a picture of hemoglobin and myoglobin. You can see that iron inside is kind of essential to the formation, as well, again, as that oxygen carrying capacity. If there's an issue of inadequate iron, not only could that impact your body's ability to produce hemoglobin, but it can also impact the size of your red blood cells. If your red blood cells aren't appropriately formed, that's also going to decrease the amount of oxygen that they can carry. And that myoglobin, again, is why particularly red meat is a good source of iron. Not to mention that there's some hemoglobin in the blood that's there, but that myoglobin is in muscle tissues as a way for muscles to be able to hold on to iron that they can then use in that final process of electron transport to produce ATP. High hemoglobin, it can be caused by a few things. Dehydration. If you are incredibly dehydrated, we've gotten to test quite a few athletes after really tough races or ultra endurance type things. And if you're super dehydrated, you're going to see a big increase in this hemoglobin. That's because your hemoglobin is measured as a concentration. It's not as an absolute amount. Altitude is something that can also increase your hemoglobin production. I think we just had a really good blog on altitude. And what it does to your body. Essentially, when you're at altitude, your body kicks in producing a lot more red blood cells and a lot more hemoglobin in order to try and bind more oxygen to be able to transport it around your body. At altitude, there's less oxygen in the atmosphere. Therefore, your body responds by trying to be as efficient with the smaller amount of oxygen as possible. Smoking is something that's associated with high hemoglobin levels. You are creating an oxygen deprived state when you are inhaling that. So that's a natural response that your body would have. And then this erythropoietin, which is not a recommendation. That's what got Lance Armstrong in trouble. That's something that's naturally produced in our body to increase the production of red blood cells and therefore hemoglobin. When used illegally in professional sport, it also boosts the amount of red blood cells and hemoglobin that you have, increasing your oxygen carrying capacity and giving you an unfair advantage against your competitors. If you do have a high hemoglobin, we would typically also see this with a high level of hematocrit. Your hematocrit is just in your blood sample, the amount of that sample that's red blood cells. So if you have more red blood cells that have hemoglobin on it, you're also going to have a higher level of hemoglobin. Sometimes you can also see this elevated as well with MCHC, MCH, and RBCs. We'll talk about that in just a couple of slides. Below optimized levels of hemoglobin can be due to your diet. They also can be due to a lot of other training factors. So since we test ferritin, which is, again, an indirect marker of whether or not you're meeting your iron needs, if you have an optimized level of ferritin with no inflammation and low levels of hemoglobin, it's likely not a nutrition concern, that you're not getting enough iron in your diet. Other things that could certainly influence that too, again, is just taking into consideration that hemoglobin is measured as a concentration. So if your blood has more fluid in it, there's going to be less of those red blood cells in it and therefore less hemoglobin. Your blood volume can increase from overhydration. We certainly do recommend that people drink a fair amount of water before their test to make the test more pleasant. If you overdo that, that can result in this kind of dilution of hemoglobin. If you have a change in your exercise regimen, which it could be, starting a new training block, maybe starting running for the first time. One of your body's very first responses to a change in exercise is to expand its blood volume. And that's just to make it more efficient at being able to pump oxygen and nutrients to those working muscles, as well as to be able to move the waste products produced from metabolism as well. And then a change in temperature, which happening all over the US at large amounts, summertime, and also not expected increases, but a change in temperature, your body also responds by increasing its blood volume so that more fluids can be released in sweat to cool the body down. If you have below optimized ferritin, though, it could be due to an inadequate intake of iron to support the production of that hemoglobin and those red blood cells. Again, if you're optimized, if your ferritin's optimized and there is inflammation, then you'd want to take a peek at that TIBC, which is coming up. Low hemoglobin. So this is an indicator, it could be an indicator of iron deficiency, especially if it's paired with low ferritin levels. And you can see some impacts on those red blood cell indices. Low hemoglobin and anemia in general certainly will feel fatigued if your body's not able to transport oxygen to everywhere in your body, inside or outside of exercise. You have a higher risk of infection. Certainly, you're going to have a decreased work capacity just due to the body's inability to produce energy to be able to contract those muscles as you're expecting. Most high or most at risk from our population is same thing with low ferritin levels, individuals that have a low intake of iron. So it could be vegans and vegetarians, again, premenopausal women, active individuals increase that even more. And then also blood loss, if you give frequent blood donation, or if there is some type of internal bleeding or something that you might not be aware of.
Absolutely.
Yep.
So, well, I want to make sure that we have time for questions. So maybe we can get through iron, and then if we can get through iron maybe in about 5 minutes and then open it up to questions, that would be awesome.
Yeah, I think the rest of it's pretty quick, truthfully.
Okay,
iron,
great.
we've already really talked about its role in oxygen transport, where it comes from. Heme iron is what you're going to get from animals. Best sources are mollusks or bivalves, clams, mussels, and oysters. You can find it in red meat because of that myoglobin. as well as just hemoglobin in blood. Liver is also an excellent source. Those non-heme sources, pumpkin seeds, hemp seeds, and sesame seeds are the best sources. You can find a high amount of iron in beans and spinach. However, they also have those anti-nutrients in them of phytic acid and oxalic acid that bind to that iron and prevent the absorption of it. Fortified cereals and supplements as well. And then just to note that heme iron is more readily absorbed in the body than non-heme iron from plant sources. Serum iron can be high if you're taking a really high dose iron supplement, like way too high at the convenience store, or not convenience stores, but pharmacies or grocery stores. Iron supplementation of 65 milligrams is typically what you find, which is way too much for most people, especially in one sitting. Ideally, if you require iron supplementation, you're going to take it in much, much smaller doses. If you have low serum iron levels, it could indicate a lower intake of iron. However, you'd want to look at that ferritin level. That's really the more stable metric. If there's inflammation, serum iron levels could also be lower just because your body's pulled that iron out of the bloodstream. Transferrin is the protein that binds to iron and transports it around. Your percent transferrin saturation is basically just telling you how full the seats on the bus are of transferrin. If you have a high level of transferrin, a lot of that transferrin is full, transporting iron around. If you have a low level of transferrin, it could indicate iron deficiency anemia because your body produces a lot more transferrin in an attempt to kind of pick up more of that iron for transportation. We kind of went through that one. TIBC, as I mentioned before, is a great marker to use if there's inflammation. And that's because your TIBC is not going to be impacted by inflammation. So your ferritin level could be completely normal, but your TIBC could be very high if your body's not taking in enough iron. How I like to think about TIBC is there's a lot of empty seats on the bus that should be holding iron that aren't. If you have a really high level. If you have a low level of TIBC, that could be an indicator that you're taking in just too much iron. All right, last slide. So your red blood cells, that's what transports oxygen from your lungs to every tissue in your body utilizing hemoglobin. They're produced in your bone marrow, requiring iron, folate, and B12. If there's inadequate amounts of any three of those nutrients, then that could have an impact on you developing some sort of anemia that can certainly lead to an abnormal red blood cells that can't transport oxygen as well. Your hematocrit, I kind of mentioned that in hemoglobin is just how many red blood cells are in that blood sample. And then our iron group is by far the most difficult group because we also include these red blood cell indices, which is just looking at the size and shape of your red blood cells. Two of them look at hemoglobin. So MCH looks at the average amount of hemoglobin on each red blood cell. MCHC is the average amount of hemoglobin or the total amount of hemoglobin in your blood sample. Mean corpuscular volume looks at the size of red blood cells. Microcytic anemia is something that can happen with inadequate iron when they're really small. Macrocytic anemia can happen if you have a B12 or folate deficiency and they're really large. And then the last one here, RDW, is just your red blood cell distribution width. Ideally, your red blood cells are pretty uniform, but if you have a type of anemia, macrocytic or microcytic, you can have a lot of immature red blood cells being released. If you have a high distribution in that, that's another signifier that something's off in your body's ability to produce them.